In this video, you're going to learn how to factor trinomials quickly. We're going to go through a number of different types like the AC method and splitting the middle term by factoring by grouping. We're going to talk about the reverse FOIL, and I'm going to show you some other techniques as we go through these 10 examples. So let's dive into the first one and we'll get progressively more challenging. So the first example, we can see it's a trinomial. The terms are separated by minus or plus. Okay, so it's like three groups. And when the leading coefficient, this a value is 1, or you don't see it like a leading coefficient that's understood to be 1, these are the easiest trinomials to factor because you just have to ask yourself what two numbers multiply to negative 12, that's the c value right here, but they have to add to this b value, which is the coefficient of this middle term. So can you think of two numbers that multiply to negative 12 but add to negative 1? See, this is understood to be a negative 1 here. Well, that's going to be negative 4 and positive 3, and you factored it. And that's all there is to it. So these are the easiest ones to do when that leading coefficient's 1. And if you're not sure if you got the right answer, you can always do the FOIL, like the first, outer, inner, and last, or you can think about it as distributing twice, and you'll get back the original, so you can see if you've done it correctly. Now let's go to another example that's like that. So for number 2, same thing, we've got three terms, leading coefficient's 1, so we say what two numbers multiply to 20, but they add to negative 21. So can you think of two numbers that would do that? So it looks like here it's going to be negative 20 and negative 1, because a negative times a negative gives us the positive. You can see that negative 20x and negative 1x is adding up to the middle term, the negative 21x, and our x times x is x squared. So that's all there is to it when their leading coefficient's 1. Now sometimes it's challenging because there might be a lot of different possibilities of what multiply to 20, and you have to go through those combinations. But for the most part, this is kind of the easiest type. Now for number 3, this one's a little bit more challenging because you can see that this a value is not 1. So what do? Well, the very first thing you want to do with factoring, always, no matter what type of factoring it is you want to look for the GCF, the greatest common factor. So you just ask yourself, is there something that I could divide out of all these terms? If there is, go ahead and divide it out. So in this case, I notice that these can all be divided by 3, okay? So what I'm going to do is I'm just going to pull that 3 out. It's kind of like doing the distributive property in reverse. You're dividing out the 3, and now we're left with this trinomial here, which has a leading coefficient of 1. So we're back to the type that we talked about at the beginning. What two numbers multiply to negative 5, but add to positive 4? That's going to be 5 and negative 1. We just make sure you bring down that 3 in front, and this is completely factored. Okay, so for example number 4 now, this one again is a little bit more challenging because that a value is not 1. So again, we look for that greatest common factor first. Is there something we can divide out of all three terms? In this case, there's not. So what do? We're going to talk about the AC method now. So the AC method is you take the a value times the c value. So you say to yourself, what two numbers multiply to negative 60? That's 5 times negative 12. So you can do that work off to the side here. What two numbers multiply to negative 60? But those same two numbers have to add to the b value, which is negative 4. So let's see, what would that be? We've got, looks like we've got 10 and 6, and we're going to want this to be a negative 10 and a positive 6 so that it adds up to negative 4. So what do we do with those numbers now? What we do is we split this middle term into two parts. We're going to say negative 10x and positive 6x, because that adds back to the negative 4x, so we're not really changing the problem. We're just splitting that middle term, okay? And then we're going to bring down the first term, and we're going to bring down this last term. Now what we have is 4 terms, and we have 4 terms we look at doing the factoring by grouping method. So what you do is you group the first 2 terms, and you group the last 2 terms. And you say, what can I factor out of these first 2 terms? Well, it looks like I could divide out of 5x. So I'm going to pull that 5x out in front. If I divide these by 5x, I'm left with x minus 2. What can I factor out of both of these last 2 terms? It looks like just a positive 6. And if I divide them both by 6, I'm left with x minus 2. Now, if at any point you're not sure if you're doing this right, just distribute back into the parentheses. You're going to see that you get this back. You're going to see that you get this back. So we know we're on the right track. And then notice that in this first group here and this second group here, they both have an x minus 2. So if we factor out or divide out x minus 2, we're going to be left with these coefficients here, 5x plus 6. Now you might be saying, Mario, what happened to the other x minus 2? Well, what's happening when we factor it out, like if I was to take this x minus 2 and distribute it to this 5x, I would get back this group. If I take the x minus 2 and I distribute it to the 6, I'm getting back this group. So it's not that we're losing the x minus 2, it's like we're factoring it out. And then this is completely factored now. You can check your work by foiling this or distributing twice, and you're going to get back the original. So again, this is probably the most challenging one that students come across. So we're going to do another example, number 5 here. So first step is we look at it and we say, is there a greatest common factor? Well, it doesn't look like there's anything I can divide out of all 3 terms. So we go to step number 2, which is to analyze, and notice that the a value is not 1. So we're going to use this AC method again, where we take the a times the c, so 2 times negative 15. And again, we can do that work off to the side. We say what 2 numbers multiply to negative 30, that's 2 times negative 15, but they add to this middle coefficient, which is understood to be a positive 1. So can you think of 2 numbers that multiply to negative 30 but add to positive 1? This is probably the toughest part about the problem, but once you find these numbers, you can see it's going to be, let's see, 6 times negative 5 is negative 30, 6 plus negative 5 is positive 1. Once we find those numbers, we're going to use them to split this middle term into 6x and negative 5x. See how that adds up to 1x? You're going to have to add the x in. We don't have that here, we just have the coefficients, but we want to put that x so that it adds up to 1x. We bring down the first term. We bring down this last term, and now we have 4 terms, which we can factor by grouping. So we're going to group these first 2. We're going to group these last 2. Some people put them in parentheses. You can do that. Some people draw a line down the middle. One thing you want to be careful of is that you capture whether it's a minus, which is like a negative, or a plus, which is a positive. You want to capture that sign. Here, what can we divide out of both these terms? It looks like we can factor out a 2x. Okay, now this part is sometimes challenging for students. So I want to give you a little hint. Once you kind of figure out, okay, I can divide out a 2, I can divide out an x, some students like to make this a fraction, like put it over 2x. This helps in simplifying. So you say, okay, 2 divided by 2 is 1, x squared divided by x is just x. Or here, 6 divided by 2 is 3, x divided by x, those x's cancel. Again, you can check your work by distributing, and you'll get back the 2x squared plus 6x. Okay, now over here, if it starts with a negative, you're going to want to factor out a negative. That's very important. And I can see that both of these can be divided by negative 5. So if I factor out that negative 5, I'm going to be left with positive x and positive 3. And you can see how this group is the same, the x plus 3? We're going to factor that out or divide out that x plus 3. So what you might want to do is the same technique we did up here, just visualize or write down that you're dividing out this x plus 3, okay? So that's going to leave us with x plus 3, which we're factoring out, but you can see this is canceling, leaving us with 2x. This is canceling, leaving us with negative 5. Now we have it completely factored. Again, if you're not sure, FOIL it out or multiply it out, you're going to get back the original trinomial. So let me erase the whiteboard. We've got 5 more examples I want to show you that are important. We're going to be talking about things like perfect square trinomials, which also comes up a lot. So let's look at that next. Okay, let's take a look at number 6 now. We've got 9x squared minus 66x plus 121. So remember, the first step is to look for the GCF, the greatest common factor. You say, is there something I can divide out of all these terms? And it does not look like there's something I can divide out of all these terms. So then I say, well, maybe because the a value is not 1, maybe I should do the AC method. So I look at this and I say, what's 9 times 121? Already my brain's starting to hurt, right? It's such a big number. I can see that this is going to be a real challenge or a real problem. So my next thought is maybe this is a perfect square trinomial. How can I test to see if it's a perfect square trinomial? Well, the first thing that jumps out at me is that I notice that this first term is a perfect square. This is 3x times 3x, okay? Then I notice that this last term is also a perfect square because 11 times 11, 11 squared is 121. And so what I want to check now is that this middle term fits this 2AB pattern. Okay, so what I do is I take A times B times 2. Does that match the middle term? Well, this is 33x times 2 is 66x. So it fits that perfect square trinomial pattern. All I have to do now is if this is minus, this is going to be subtraction. If this is plus, this is going to be addition. And that's it. That's all there is to it. Now, if you wanted to check your work, you could write this as 3x minus 11 times another 3x minus 11, FOIL that out or distribute twice. You'll see that you're getting back this original trinomial. So if the numbers seem to be kind of off the charts, you might want to check and see if you're dealing with a perfect square trinomial. You can do it the other way using the AC method, but it's going to be pretty challenging to find out all the different possibilities that are going to work out to multiply to a times c, but add to b, and then you're going to split the middle term. So you might want to take a moment and see if you're dealing with a perfect square trinomial. So let's look at another example, number 7. So what jumps out at me is I say, oh, this is a perfect square because this is 4x times 4x, okay, times itself. 81 is a perfect square because 9 times itself. 9 squared is 81. The only thing that I have to do now is make sure that that middle term fits this 2ab pattern, meaning 4x times 9 is 36x, doubled or multiplied by 2 is going to give us 72x. That matches. Because this is addition here, this is going to be addition here. If this was minus 72x, this would be minus 9. And it's the quantity squared, meaning it's 4x plus 9 times another 4x plus 9. And you've got it factored. So look for those perfect squares, a squared and b squared. Take the square root to find your a and b. Then take a times b times 2. If it matches, you've got a perfect square trinomial, and it's going to be very easy to factor, very quick. Okay, for number 8 now, this oftentimes comes up in these factoring problems. It starts with a negative. Now, this really bothers me, okay? And it probably bothers a lot of people. So what do I do with that negative? I recommend factoring out the negative. So you might want to check and see if there's a greatest common factor, like maybe you can factor out a 2, a 3, a 4. But if it starts with a negative, factor out a negative 2 or a negative 3 or a negative 4. In this case, the only thing I can factor out is a negative 1. So let's do that first. We're going to just factor out a negative 1, or you can write it just as negative, and you're left with x squared minus 7x minus 18. See how the signs, they flip, they change to the opposite? Now, because that leading coefficient's 1, we say, oh, this is easy, right? I just have to multiply to negative 18, but add to negative 7. What two numbers multiply to negative 18, but add to negative 7? That's going to be negative 9 and positive 2. And that's it. Just make sure to bring down that negative, and that's completely factored. So the ones where the leading coefficient's 1, you take a big, deep breath and say, this is easy, right? It's the ones where it's not, that's where we have to dig in, okay? So for number 9, let's go through the steps. And you might want to pause the video and see if you can do these last two on your own because they're a little bit more challenging, but you can test yourself and see how good you've gotten at this. First thing I look for is the greatest common factor because that's going to make all the numbers smaller. It's going to make my life a lot easier. But unfortunately, in this case, there's not a greatest common factor. So I go, okay, well, am I dealing with a perfect square trinomial? Well, 20 is definitely not a perfect square, so that's out, right? So I'm going to have to do the AC method. Okay, so I'm going to say a times c. Okay, what is that? So I'm going to go off to the side here. What multiplies to 6 times negative 20, which is negative 120? That's a times c. But those same two numbers have to add to our b value, okay, which is positive 7. If this is a minus 7, then it'll be a negative 7. Now, when it's a larger number like that, negative 120, it might not be obvious to you what the two numbers are. So I'm going to give you another skill or technique that you might want to utilize, and that's to do a factor tree. Don't worry about the negative. Just take the 120, break it down into its prime factors, okay? Anything that's divisible by just 1 in itself. So you see these numbers right here, okay? 2 times 3 times 2 times 2 times 5, that multiplies to 120. But what we're going to do is we're going to try to make two groups, okay? Because when you make those two groups, that's going to multiply to 120. So for example, I could do, let's see, I could do maybe, let's see, what could I do? How about this right here? I'm going to take these 2's. See, 2 times 2 times 2, that's 8. I'm going to take this 5 and this 3, that's 15. 8 times 15 is 120. So let's write those two numbers down. But if I make the 8 negative, negative 8 plus 15 gives me 7. So that's kind of a clever way of figuring out what two numbers multiply to 120 quickly. You just try to make two groups, okay, because obviously all the numbers are going to multiply to 120. That's how we got to this prime factorization. But by breaking up to two groups, you can go through the different combinations. Like I could have done like 6 and 20, you know, so you just make two groups. Okay, so that's another technique. Let's split that middle term now. So negative 8x and 15x. Now, a question students often ask me, they'll say, Mario, does it matter if I put the 15x here and the negative 8x here? It doesn't matter. The order doesn't matter. You're going to get the same result in the end. Okay, then we're going to split the middle term and factor by grouping. So I like to just kind of do this, make a little bracket, make sure you capture whether it's positive or negative. Factor out the greatest common factor, which is going to be 2x. That's going to leave us with 3x minus 4. Here I can factor out a positive 5. That's going to leave us with 3x minus 4. I'm going to divide out the 3x minus 4. Okay, that's like factoring it out. You're dividing it out, and you're left with these coefficients, 2x plus 5. If you're not 100% sure if you got it right, you just FOIL it, first, outer, inner, last, or distribute twice, combine like terms, and you should get back the original. Now, go ahead and pause the video. See if you can do this last example on your own. While you're doing that, I want to let you know that if you're enjoying my content, you've been following me for a while, and you want to go deeper, a lot of times people will comment in the comments, will say, Mario, I wish you were my math teacher. And in a certain way, here on YouTube, I can be. If you want to join my channel membership at the additional videos level, you can have access to all my math courses. So my Algebra 1 math course, my Algebra 2/college algebra video course, my pre-calculus course, my full geometry course. And then if you want to prepare for the ACT and the SAT, I've got many videos on those topics. I have 2 courses that kind of go through the important concepts and problems that you're going to want to know. And then I also have midterm and final exam reviews. So if you're practicing for those important tests, you can check out those midterm and final exam reviews. And I have some other videos on there as well, and I plan on adding more. So it's almost 400 videos that are on that membership section. So if you're looking for that little something extra and you want it, you know, like my courses, you want access to that, and you want to be able to kind of go through some of these more deeply with me, join that channel membership. It's very flexible. You can join for a month and try it out, see if you like it. Some people have been members for, you know, a year, 2 years. Some people just join for a while when they need it, and then they take a break, and then they come back when they need it again. Whatever you want to do, it's flexible. I want it to help you. So check that out. Last problem. Okay, how do we do this one? Is there a greatest common factor? Unfortunately, no. Is it a perfect square trinomial? No, these are not perfect squares. Okay, we have to do the AC method. So we're going to take 20 times negative 18, which is negative 360. Okay, that's a big number. What 2 numbers multiply to negative 360, but add to this middle coefficient, negative 9? Okay, I don't know off the top of my head, so I'm going to use this factor tree again, okay? So let me see if I can put it here. We're running out of space. So bear with me. This is 36 times 10. This is 6 times 6. 10 is 2 times 5. 6 is 3 times 2, 3 times 2. All these numbers will multiply to get 360. But we're trying to make a pattern so that we know that one has to be positive, one has to be negative, right, to get negative 360. So we want 2 groups in such a way that those 2 numbers are going to add to negative 9. So do you see what that might be? Let's see here. I'm thinking here. Let's see. I've got maybe 20 and 6. No. How about this is like 9 and maybe I could do, let's see, maybe I could do 18 and 20. No. How about, let's see, this is 12. Oh, I think I maybe have it. Let's see if I do 12 and no, that wouldn't work. 30. Let's see. I should have prepared a little bit better here. Let's see. So let's see what we've got. So this is 8 and no. Help me out here, guys. Let's see. So this is 6 times 2 is 12. No. Let's see. What would this be here? Let's see. What else could I do? I could do 9, 18, 36, and 10. No, I could do 5, 10, 30, and 12. No, let's see, what can I do here? This is 4, 12. Let's see, I'm trying to get negative 9, aren't I? Now, if you can't factor it, it's called prime, but I think this should be factorable. Let me see. What am I missing here? So this is 4, 8, 24, and 15. There we go. Thanks for bearing with me. Oh my goodness, that was a tough one. So that's the technique of trying to make 2 groups can be a game changer because it's hard to guess these numbers. And we know that it's going to be negative 24 because it has to add it to negative 9. Okay, so we're going to split this into 2 groups. Okay, and now we are going to do our factoring by grouping. So if I can factor out a greatest common factor, which is 4x, factor out a greatest common factor, which is going to be 3, I get the same group, 5x minus 6, that I can factor out. And I'm left with these coefficients, 4x plus 3. If you're not sure if you got it right, FOIL it out. You're going to get back the original. and you got it. So if you want to learn more about factoring, okay, not just these trinomial ones, but difference of two cubes, sum of two cubes, difference of two squares, some of the ones that are of higher degrees, I'm going to show you all the different techniques for factoring in that video right there. Follow me there. We'll get some more practice. You can test your skills. I'll see you over in that video.